Hello everyone. So today we are going to do our classic threesome problem. So let's go through the problem first. So this problem statement says that when you are given an integer of nums, then we'll have to return all the triplets, all such three numbers, which when adding will result to 0. Okay, as simple as that. So for example, if you see here, so in this input, so here -1 plus -1 results in -2, and then this 2 -2 plus 2 is 0. So this is such a triplet which will result in 0. Okay, so we'll have to find all such triplets whose summation will result in 0. So that is what our problem statement is. And I think we have to return all the distinct, since it is we'll have to return all the distinct set. We don't have to return the duplicate one, so we'll have to keep that in mind. And if you see in example 2, 0 1 1, there are no any triplet that will result in 0, so it's an empty array. Okay, so here you can see all these numbers are same, and adding it up will result in 0. So that is our problem statement. So let's go ahead with the solution. So the first solution, the brute force way, I would say, is like take one element and then run a loop for the rest of the element, and then take second element, run a loop for the rest of the element, right? So when you take when you do it for each element, it will become n cube. Like if you take -1 in your first iteration, and then here, right? And for second iteration, if you will take the next element, from 0 to -4, right? So it will check from 0 to -4, and then for the third iteration, so suppose for example 0, it will do it like this. So this will become n cube. Okay, so that is the most simplest solution that you can think of. But is there any efficient approach? Is there any optimized way? That's what we have to think about it. So I think one optimized way is to make use of our two pointer technique, like iterating for each element. Okay, like iterating for each element, but for to avoid second and third iteration, we will combine it into one iteration by using two pointer technique. Like for example, if we're doing for each number, right, we'll take -1 and then 0. So this is unavoidable, like we have to do it. Okay, 1 2, but for we have found first triplet. Now to check for two more inputs, we will not run two loops, not run a loop of n square, but instead we'll use a two pointer technique from 0 to -4. Okay, first element we have considered -1, and for 0 to -4 we'll consider two pointer technique. So in a two pointer technique, what we do is uh, we will consider two pointer, like one is low, which will point to 0, and the high, which will point to -4, and then we will add it, and we will see that whether it the sum matches to our target or not. So in our case, what is the target? In our case, the target is the negative of this number. So here if you see, the first element is -1. So from the remaining element, if there exist any two elements whose sum is +1, that means we have our triplet, because that triplet +1 and -1 will result in 0. Okay, so here we will do a two pointer technique to check if it matches with +1, right? So we'll see 0 and -4 result in +1 or not. It doesn't, right? And also one point that I am missing is two pointer technique will work with the sorted array. So what we'll do is here we'll sort it out. So we'll run two pointer technique for this element, right? 0 for the remaining element if it is sorted, in 0 comma 1 comma 2, right? Here it is -4 and then -1, right? So it will run for this. So, and we'll say that first our low is pointing to -4 and our high is pointing to 2. So -4 plus 2, and our target is the negative of this number. So negative of this number is 1, right? So we have to find any two number which will result in 1. Okay, so when we are doing -4 plus 2, it result in -2, which is smaller than 1, right? So when it is smaller than the target, that means we need to find something which is bigger than the current summation that we have found. Like -4 plus 2 is -2, right? So this doesn't meet our condition, this is not our target. So what we have to do is, and this summation is smaller than our target, so what we have to do is we'll have to find something that is higher than that value. And to do that, what we'll have to do is we'll have to move the left pointer, the low pointer, towards the right side, because towards the right side the numbers are higher, right? So there is a chance that it will lead to a higher number, right? Higher number than -2. So -4 and 2 result in -2. So it doesn't match our condition, so we'll move forward by what? We'll update our low. So now our low pointer will not point to -4, but it will instead point to -1. Okay, and our 2 remains same because high pointer is still 2. So now low pointer is -1, and -1 plus 2 result in 1. So we have meet our target, right? So hence we have found that -1 and 2 meets our target. So our triplet is our the two numbers from this array is the second one, -1 and 2. So hence our so it will be -1, 2, and our main first element -1. So this is our resultant triplet from this computation. So next we'll do for 0, and for 0 this is our second element, so we'll check for all this number, right? All this number, and when sorted it will become -1, and sorted, so this will become -1, 1, 2, and this -4 will come here. Okay, so we'll repeat a similar process. So that's what our approach is. Okay, so let's start with the coding then. So first of all, what I have to do is first of all what we have to do is let's define the length first, and then we'll run a loop for each of the element. For I in range n. So when this is our number, we don't have to run for each of the elements. So we'll run for -1, we'll run for 0, we'll run for 1, we'll run for 2, and we'll not run for -1 and -4, because after when we consider -1, so there are no more 2 elements left after this, right? So that's why we will we'll do it till n -2. So when it is n, then it will run till this, but when it is n -2, so it will run till here. Okay, and also instead of taking each element and then sorting for the rest, taking each element and sorting for the rest, so why don't we sort it in the initial at all? So in that way the entire array will be sorted, right? So that's what we'll do. So here if you see, we'll run it. sorted. And then after sorting, this will become like this. Right, yeah. So let's do this first of all, and now we'll also have to store our result in triplets. So we'll have a result list where we'll store all the triplets. Next is for each iteration we are finding a triplet. So in our first iteration, like for -4, what would be our target? Our target is the negative of -4, that is 4. So that means that for the remaining element we'll have to find any two elements which will result in 4. Okay. So in that case we'll define our target as nums of I, negative of nums of I, or rather I would say 0 minus nums of I. Okay. And then now what we'll have to perform a 2-pointer technique for all this number, right? So how will we do it? Let's create a function for this. Let's say that define to sum, it takes nums and a target. So we are finding any two elements which result in this target. Okay. And a result will be, we can directly return a triplet as well, but let's return this. We'll return all distinctive all distinct two numbers which will result in the target. Okay. That is our case. And here what we'll do is, instead of there, now here, and also we need an index, right? So here when we're doing for I is 0, we are running for I plus 1 to this one. So our initial low and high we need to define it. So that's what we'll say, that this is our I and this is our j. J is always the last element. And now what we'll do is, while I is less than j, okay, so that's our we'll run from here to here, like we'll check -1 and 2, and if it matches, like if it results in 4, then we'll check for the rest of the values if there are any other two pair that will match. So we'll do it like this, we'll check for this, and then finally we'll come to the middle element 0, right? So in the, or otherwise if it doesn't matches, then we'll check for -1 and 2. If it is smaller, then we'll not update 2, but we'll just update lower value -1. But since here it is same, so we'll go more further and we'll check for 0 and 2. Otherwise if it is higher, then we'll if it is higher than the target number, then we'll just decrement a higher value, not a lower, not increment a lower. So we'll check for -1 and 1, like this. Okay, so we'll go ahead with this, and we'll say that we'll, until we meet the middle element, or the point when the two pointer collide, right? So this, I'll rather say low and high. Okay. Low and high, and while low is less than high, what we are doing is, we'll first of all what we're doing is we're checking that whether low plus high is equal to our target or not. That is our uh, condition of two pointer, right? So if it is equal to target, then we have found our pair. Okay, and actually we can have multiple pairs, right? Yeah. So let's do one thing. So we'll return the resultant triplets only. Okay. So here we'll set triplets. If it is equal to target, then that means we have found our first triplet, and that is triplets dot append. And what are our triplets? So first of all, it is our nums of low. Oh, first our first element is obviously the target, negative of target, which say rather 0 minus target, and then our second element is our nums of low, and our third element is nums of high, right? Let's see. Otherwise, if it is not equal to target, what we'll say that we'll check if it is, and it is not this low and higher index, right? So we are not checking index, but we are instead checking the number of that, right? So high. Okay, and here if nums of nums of low plus high is less than target, that means here if you see now, if it is less than target, then we'll have to find a more greater number. So for that we'll just increment a low. Okay, and what is our last condition? Our last condition is equal, we have checked. Less than, we'll check. The last condition is our greater, right? So if it is greater than target, that means we'll decrement that. Okay, and finally we will return our, and this triplets dot append, it should be a list, the list of triplets we are returning, and finally we are returning these triplets using a two pointer technique. Now here one more thing is, like, let's see like how this works. So here for -1 0 1 2 -1, so initially low will be pointing to -1, and then high will be pointing to 2, right? So here it is. So in this case, like -1 plus 2 will result in -1 plus 2 will result in 1, and our target was 4, right? -1 plus 2 will result in 1, and this 1 is less than our target, right? So we'll increment a low plus 1, and now it will point to our next -1. So again -1 plus 2 is 1, but here if you see, like, if to avoid this double computation, right, because it is checking the same thing, -1 into, again it is taking the -1 into. So to avoid this, what we can do is, like, once we have once we have run this iteration, once we have checked it, then we'll say that if if nums of low is equal to nums of low plus 1, right? Or maybe if there are multiple -1 like this, right? So we'll first check -1 and 2, and then we'll next low pointer should be our 0, right? So we'll skip all these elements, and to do that, we'll, instead of running if, we'll run a while loop. And understand that even if we're running iteration, it is still a single iteration only, because we are this while loop is just avoiding the numbers. Okay, so we are left off with the remaining numbers only. Okay, so here we'll say that while nums of low is equal to nums of low plus 1, we'll just increment the lower value, And also same goes with the higher side. If suppose assume there are multiple same elements and we have already checked with -1 and 2, so next time we have to check with 1 and 0 rather than -1 and 2 once again. So that's why we'll do it for high as well. So while nums of high is equal to high -1. Okay, so this is one part of the computation. So these are main logic, and this logic is to avoid all the duplicate values, avoid computation of repetitive repetitive computation. So here if you see, what will happen is first our I points to -1 and 2, j low points to -1 and high points to 2, and then -1 plus 2 is 1, which is not equal to our target 4, right? So our target is 4 here, so which is not equal to our target 4. So we'll, and it is lesser than the target 4, so we'll increment it. But while incrementing, we see that it's the same value, so and these will avoid that, and it will now point to low will point to 0, but right side it is not it is a different number, right? So this will not run. So now our low will point to 0 and high will point to 2. So 0 plus 2 is 2, better. Now it's a little bit more than the earlier value, which is -1 plus 2 was 1, and now 0 plus 2 is 2, but still it is smaller than 4. So we'll again increment it 0, and we'll check for the repeated value. There are no repeated values, so we'll increment it and it will go to 1. Now 1 plus 2 is 3, and it is also not equal to any triplet. So finally one low becomes low will be incrementing, because 1 plus 2 is 3 and 3 is still less than 4, so it will increment. So now low and high will be pointing to 2, at which point this will be, I mean, it will come out of the loop, right? So saying that there are no any triplets, so it will simply return an empty value. Okay, and so that is what our logic is. And here if you see, so what we have to do is, now let's call this function. Okay, so we are doing toSum. So self dot toSum, and it is returning a value. It is returning what? It is returning a triplet. Okay, self dot toSum, and the parameter that it takes is nums target low and high. So nums, and our target is target, and our low is the so if we're doing for, if our I is -4, then low would be the for the remaining, right? So low will be the I plus 1. Okay, I plus 1, and then what is our higher number? The high is always the last element, so it will be n minus 1. Okay, the last index is pointed by n minus 1. Okay. So now we'll see that if it is an empty or not, right? So if there are no triplets, we don't have to do anything. But if there are triplets, if there are, suppose there are multiple 2 or 3 triplets, then we'll just append the triplets to our result. Okay, so we'll first check that if length of triplet is greater than 0, saying that like there are at least one triplet we have found by performing toSum. So if it is greater than 0, then we'll just add it to our result, and we can do it by result plus triplets. It will not be triplet, it will be triplets. There can be multiple triplets. So result plus triplets. Okay, I think, yeah, that's it. This is the way to do it. and finally we'll return our result. Yes. Let's check these ones. Index out of range. While nums of low equal to nums of low plus 1. Low plus 1 is fine, but again we'll also have to see that it doesn't exit our higher value, right? And low is greater than high. Low is less than high. And similarly here also, and high is same thing, right? Low is less than high, because that's our window. Some index out of range. What happened is, I have to put this. We'll first have to check whether low is less than high or not, whether it is in the window or not, and then check the other condition. Time exceeded for, okay, here we have missed one important thing, that we'll have to obviously increment, lower our window to search for other values, right? So in that case we'll increment low plus 1, because we have found one triplet. We'll check for rest other triplets if there are any other triplets which will result in that target. So for that we're incrementing both the values. So that is one important thing that we have missed out. But here also we are getting again the triplets. We -1. I think there is one more thing to consider, that like if we have found triplets, why are we getting, we need to get two values, but there is the same value is repeating. So we have done it, we have considered a distinctive case in our two sum, but we have not considered it here, right? So here also we can get a repeated -1, right? So here if you say we'll do for -1, we'll run the rest of this, and again there is -1, for this -1 also we'll run rest of these things. So there can be duplicate elements here as well. So to avoid that, what we'll do is like do like this. We'll compute this only when the nums of I is not equal to the previous value. Okay. But for the first iteration, I'll not have nums of I So if it is I equal to 0, then we'll have to run, because we don't have I minus 1, right? So if I equal to 0, then it will not even check this thing and it will run. And second time when it is from the first element, then it will see that is it equal to the previous number or not. If it is equal to the previous number, then it will not check, because we have already checked it. Then I think this should work. Yes. Okay. So this is running. So let's submit. Okay, here is a wrong answer. It passed 120 test cases, so there are still some bugs. -202 resulting in 0. -2 plus 2 is 0, and then -2 1 1. This should also result in 0. Yes, -2 1 1. But this is not found. We'll take out this case of this. Here we need this is not considered for some reason. So what happened? Let's try to do a dry run here. So after sorting, our nums become this: -2 0 1 1 2. Yeah, so for -2 it will run. So there are two values with -2, right? So when it is taking -2 0 1 1 2, for this 0 1 1 2, and it is running here, 0 1 1 2. So here 0 plus 2 will result in, and our target is 2, right? So target is 2. So 0 plus 2 will return, we'll have that target, and then there should be one more target. We got this to -2 0 and 2, but there should be one more target, that is -2 1 1, and we have two values, but it is not considering that. 1 and 2. So when 1 and 2 is added, it results in 3, so we need a lower value, and we'll have to check for 1 and 1. Okay, but here we are avoiding this by running this loop, right? So what we did is we kind of tried to avoid the repeated number, and while doing that we have avoided all this 1 1. So we checked 1 and 2, it didn't result, and then we avoided all the 1, but that should not be the case, right? So if it didn't result, then we should not do it. We should not avoid the repetitive numbers, because from the right side we might get one more same number, and that so that's what happened here, right? So what we have to do is we have to avoid the repetitive numbers only when it is matched. So that makes sense, right? Yes. So we'll do it here. So instead of doing separately, we'll do only when it is matched. Okay. So only when the low is less than high and it is equal, then we'll do it. Yes. Let's check this now. Still it is avoiding. Actually, after incrementing, it is already like, for example, got it. When we're running for this, actually this 0 here, after finding that 0 and 2 matches, and it is already pointing to 1 1, right? So in that case we don't have to do, low and low plus 1, but instead we can say that if low is equal to low minus 1, because low is already pointing to the next element, and we are just checking that is this next element equal to the previous element. Okay, similarly here as well, we are just checking that is this decremented high value is equal to its previous element, that is your high plus 1. Okay, is the new lower value equal to our previous value, and is the new high value equal to our previous high value. Okay, so this is what it does. Yes, let's submit this now. Nice. So that's our threesome problem. So what we did is we just sorted the list first, and then for each element we did a two-sum for the remaining element. So this is our first iteration, and then here we are performing two-sum whose time complexity is O of n, because we are running for the remaining element using two-pointer technique, right? So it's just O of n only, even though we are using this while loop, it is just to avoid the repeated number. So when we are avoiding the repeated number, the window of this is being reduced. Okay, so that's how it's running in O of n, and these are the first iteration is again so our resultant time complexity of n square. And if we're talking about space complexity, then of course to store the result we'll have O of n. Okay, so that's it. That's our threesome problem. I hope you liked it. If you have any doubt, you can write it in the comment below. Thank you so much for your patience. Thanks a lot.